I think it is surprising to me just how supportive the community at MIT is. Again, coming back to the discussion we had earlier about people not being competitive, even beyond that, people are willing to help. People are willing to explain it to you. They're willing to say, this is what helped me. Maybe you can try it. People want you to succeed, even though it is very challenging. And again, I didn't have that perspective at MIT when I heard about it. I mean, as a girl not from the city and not well-versed on the world, I had this very distinct image of MIT in my mind of like penthouse buildings and a bunch of like really nerdy people like at each other's throats, competing with each other, a bunch of computer science people. And the parts of MIT that I find myself connecting to the most just aren't like that. It's a very supportive place in terms of academic.
Hi, I'm Emma Zareen, your host and a 16-year-old engineering student, policy enthusiast, and hopeful future STEM school survivor. Welcome to She Persists. Before we dive in, I just want to take a second to say how grateful I am for each of you. Every listen and every bit of support genuinely means the world to me. When I started She Persists, it started as a little dream to share real stories of young girls in STEM who are challenging norms, finding their place, and inspiring change. Seeing that idea come to life has been so rewarding, and honestly, it's just the beginning. If you've been enjoying these conversations, I'd love for you to be a part of our community by following this podcast. It's one of the best ways to help us grow, share even more incredible stories, and connect with a wider audience. And I hope the conversation doesn't end here. I hope you carry these stories with you and let them be a constant reminder that your voice truly makes a difference. In today's episode, I'm joined by Jaylee Bouwhuis, a first-year student at MIT whose story is such a thoughtful reminder that loving STEM doesn't mean having everything figured out right away. Jaylee shares what it's been like to transition from high school to MIT, from navigating the intensity of P-sets and homesickness to finding community in a place that can seem overwhelming from the outside. We also talk about her evolving interests in physics, astronomy, earth and planetary sciences, and research, along with her love for science communication and the bigger question of how STEM connects to the world around us. And one of my favorite parts of this conversation, Jaylee also shares her love for dragons, stories, and philosophy, and how that's shaped the way she thinks about science, curiosity, and what it means to be human. This episode is such a special one, with exploration, identity, and learning that it's okay for your path to keep changing as you grow. So with that, let's get into it. Here's Jaylee Bouwhuis. Hi, Jaylee. Welcome to the She Persists podcast. I'm so excited to have you with me today and to hear about all the amazing things that you've done so far and are continuing to do.
Thank you so much for having me, Emma. I'm excited to be here, excited to talk a bit about my experience. Whatever you want to ask me, I'm interested to discuss and talk about why I love STEM so much.
Yeah, amazing. So I'll just jump into the first question then. To start, could you introduce yourself and share a little bit about who you are and what you're studying at MIT right now?
My name is Jaylee Bouwhuis. I grew up in a suburban, rural-like part of northern Utah. So out west where the buffaloes are. I am a current first year at MIT. So MIT first years are technically undeclared. What this allows me to do is I have been taking my general institute requirements, Physics 1, Physics 2, chemistry, biology, the things that my college has decided are important things for all of us to know. And besides that, I don't currently have a dedicated major in mind. When I first came to MIT, I thought I was going to go into astrophysics. So physics is the study of, generally speaking, how things work. Right now, physics tends to look a lot like quantum particles or very subatomic particle interactions. You have quarks, you have quantum soup. I recently took a class about time dilation and lens contraction with relativistic speeds. So relativity, all the buzzwords that you hear in physics. And astrophysics is a subset of physics that you're more focused on the study of quasars, Newton stars, things of that nature. Space at large, but through a more scientific lens. And after learning more about what an astrophysicist does for research or job, I've come to the realization that I may not be the most adept at that work or want to do it. So I'm currently planning on majoring in course 12, which is Earth, Atmospheric, and Planetary Sciences. So with that, I still get to learn about space. I get to take classes about astronomy, but I also get to take classes about geology, classes about climate change. This is a little looser in that I might pivot and I might go into more engineering if I decide I want to be more of a civil engineer, or big pivot if I go into biomedical engineering. So my interests tend to be a little all over the place simply because I love science and I love learning, but that's a rough introduction to where I stand in the scientific field.
I think that's incredible that you have such a diverse field where you can kind of go in different directions and explore a lot of your interests. And you also have so much time. You're still a first year, so you've got a lot of time to make that decision for yourself.
Absolutely.
Tell me a little bit more about when you first arrived at MIT. What was that transition like going from high school into that kind of competitive environment?
Ooh, good question. My first instinct is I moved very far from my support network, some friends at home that I absolutely love and who are what I consider to be like my people. So being 2,100 something miles away from that was very difficult. I think anyone who's moved anywhere can probably relate to that experience. So I think the first thing is homesickness. And then the transition to MIT, I had this thing called FizPop, or an FPOP, which is a first year pre-orientation program. The idea basically being you're interested in this field of study, come to MIT, see what this field of study is like at MIT, learn some things about Boston, meet some cool people, et cetera, et cetera. I went to the FizPop, so physics pre-orientation program. It was very enjoyable. But with that, it also allowed me to be here for about a week earlier than a lot of my class. So that was probably helpful for me. Campus was a little bit quieter. I was able to get moved in. My roommate wasn't back yet. Things like that. MIT is challenging. I'm a student who attends MIT. In high school, I was very overachieving, 4.0 GPA, all the stereotypes that you can think of that comes with being that student. And transitioning to MIT, you find out very quickly the standard of what is expected of you is very high, and it is very challenging here. People tend to refer to MIT P-sets, so problem sets that we do every week in our classes, as being hard enough you have to do it with other people. And it's commonly thought of that you are all traumatized together, and they are very difficult. I would agree with that. That's still something I'm actually still grappling with, even this semester, is having to learn how to ask for help from other people, from my teachers, from my peers, because that is a skill that one has to develop. And for myself and many of my peers, we didn't have to do that in high school. That was a big challenge in transition to MIT. And then the final thought I have is just adulting in general. There's a lot that goes into it, being responsible for my eating habits, my sleeping habits, for making sure I go to doctors every year, taxes, things like that. Things you don't think of that are a big deal until it's just you having to remember all of them can be challenging. So those are kind of my thoughts about the transition. It's been good, but definitely interesting ways it's been difficult.
Yeah, I can imagine how difficult it must be to adjust to that kind of super, super rigorous environment. But can you tell me a little bit more about what your first week at MIT looked like in terms of, classes, schedules, stuff like that?
My first thought is that it was very fast. The experience I had a lot in high school was the first week or so. It would be class after class of going over the syllabus, talking about expectations, talking about what you could expect to learn. And maybe in your AP classes, you would briefly start on a topic. At MIT, it was more of they posted the syllabuses about a couple days before if you were lucky. Not all professors are like that. My professors were. And you go over the syllabus for about 5 minutes. Are there any questions? No? Cool. We start immediately. And my first class at MIT was my chemistry class. And I had never taken chemistry in high school. So that first day, I remember the chemistry class ended and my head fell onto the desk. And I kind of thought to myself, oh dear, we're not in Kansas anymore, Dorothy.
Yeah, wow. I can imagine just jumping straight into a class that you'd never taken before that must have been hard.
It was good though. It's not something I want to do, but I love learning about it. There's fields like that where you go, I love that there's other experts in this who can explain the field to me. I love learning about this. And then one kind of really cool thing about my experience during the first week was at MIT, there are 3 modes of student first year advising. There is the standard mode, which is you get one professor to a student. Generally, the professor will have around 15 students, I believe, 15 to 20. The second mode, which I don't remember because it doesn't pertain to me. And then the third mode, which is called a learning community. So with a learning community, you tend to have roughly 3 to 6 professors that all form like a cohort or like a group together. And then they take on about 15 to 20 students each. My learning community is about 10 each. The point is, though, is that roughly 40 students get into these learning communities. And depending on the learning community, they can look different. My specific learning community is the only humanities-based one on campus. It revolves around philosophy, debate, discussion, and the value we place on what does it mean to be a human being existing in the world? What do we want with our lives, et cetera, et cetera. So with that first Friday was my first seminar with Concourse. With Concourse students, you have to take at least one GIR with Concourse. So you had your choice of chemistry, physics, or math. I took all 3, but that's neither here nor there. And then you have to take the seminar class. So seminar that first Friday, we had a debate discussion, like conjoined together. Normally during the week, we'll have either a debate or a discussion. This last week, it was about gene editing and morality of gene editing. That first week, though, the conversation was a discussion about cell phone use and policy. And the debate was resolved. Concourse Lounge should be a no phone zone, was basically the thesis. And so that was a really important and positive moment for me at MIT. I put a lot of value in discussion. I put a lot of value in debate and listening to other people. So having this somewhat less stakes debate during the first week, but still interesting and still something that there was discussion to be had around and different values and different points that one can learn from was really important for me and really enjoyable. That about summarizes my first week, was being surprisingly challenged, but also being able to be a part of the learning community and seeing the value that discussion and debate can have still as I move into being a more involved adult in society. And then with Concourse moving forward, because it's a learning community, I see a lot of those same people in a lot of my classes. We have our lounge where we can hang out together and work on P-sets. Very awesome experience.
Yeah, I think that's really interesting that you guys have that kind of community or built into your culture where you're having discussions about like these topics, whether they be STEM related or not directly STEM related. I think STEM is such an interdisciplinary field in that, you know, humanities is so connected with it in so many ways, and being able to have those discussions and those conversations and debates that's super cool. But so MIT has a reputation for being an extremely intense academic place. From your perspective, what has the culture in terms of the community, the maybe competitiveness, or things similar to that actually felt like so far?
Before I answer your question, I do want to mention that like STEM absolutely, humanities and STEM may not be entirely related. At least the value I have is that it is important to be a humanities person so it can inform what choices you make as a STEM researcher.
Yeah, I totally agree with that. I was actually having a conversation the other day with someone talking about how people, especially in humanities fields, it can be really interesting to also have a STEM background because it allows you to bring in a lot of like a technical expertise into these things that are affecting people every single day. So yeah, I think that's definitely a super important point.
Learning is such a powerful skill. Discussing MIT's culture. This is actually something that I've been having a lot of discussion with friends about for a whole plethora of reasons. The burning question about competitiveness, the answer is it's not very competitive, surprisingly. People here tend to be generally very supportive and very kind people. It helps that we are at an institution where we're able to be pursuing our dreams and that we worked very hard to be here. Those definitely factor into it. But in general, I would not call an MIT a very competitive place. I would call it a culture made up of a lot of perfectionists and a lot of students who know how to work really hard and or students who had things come easy to them. It's a weird both being true at the same time. What I mean by that is MIT has this phenomenon where everyone is always doing something interesting. For example, there's a club on campus where it's called HEMA. It's an art of sword fighting where you get to use like steel blades, long swords, pole arms, daggers, rapiers, and we practice fencing or sparring. Really cool, interesting thing that I get to do. It takes up a decent couple of hours and throw in the opportunities to work on Europs, to learn languages, to learn metalworking, we have, I think, 7 makerspaces on campus. Makerspace being a place where you can work with saws, hot metal forges, 3D printers. We have 4 lasers, at least in Metropolis alone. I can go on, but the point I'm trying to make is that there is always something interesting to be doing at MIT. So much so that there's so little time to just exist as a person. And I've been thinking a lot about the fact that if I wasn't in Concourse, which is a community and it forces people to be in the same area together, to work on P sets with the same people roughly every week and to be around people, and that helps create community here faster. That is not true of some of my peers who are not in Concourse, who I know are a bit kind of feeling a bit lost and they're trying to get tethered in MIT's culture. Because there is this culture of go, go, go here. There's this culture of always be doing something. If you're resting, it's resting so you can work harder tomorrow. So it's less a competitive atmosphere and more of a workaholic atmosphere, which also leads to some issues, but different than I think people would expect if you just heard about MIT.
Yeah, I think definitely. I think from like an outside perspective, just hearing about MIT always makes it seem super competitive. But yeah, it's interesting to know that that's not exactly how the culture is there. But yeah, I think having that community that you were talking about in Concourse is super important because it allows you to be connected with a lot of people constantly. So you've given us a sense of who you are and what MIT is like for you in your experiences so far, at least. I want to kind of go back a little bit in your journey. So you mentioned that going into MIT, you were interested in astrophysics. How did you first find that interest in high school?
Ooh, I love this story. Okay. So I went to a school that was a weird dichotomy. It's one of the poorest, so in terms of socioeconomic, like the student population, the percent of students who are in lower socioeconomic statuses in my state. But it was also the school with the IB program and the AP program. Fun little side tangent. One of the only AP classes it didn't offer was AP Physics Mechanics and AP Physics E&M. So I was a student who needed science credit to graduate, as one does. And I had an interest in taking a class over at another high school nearby. My friend was going there to take a chemistry class. I was hoping to get into the chemistry class. It didn't end up working out. The class was full. So I, having already made these plans with her, decided to just take a physics class there that was at the time 7 students. It ended up being a total of 9 students, 4 of which were from my school and 5 of which were from that actual school. Very small class. And so I went into this class not knowing exactly what physics was. I was a very math-centric student. I had done calculus in the year before, so in my sophomore year of high school. I loved it. It was great. Challenging, but great. And I hadn't really given much thought to the applications of calculus or to the ramifications of what this mathematical field could mean. And so when I went to this AP class in my junior year, I remembered like the first or second day, the first time my professor, he had a Barbie doll and a string that he would tie into the Barbie doll to like demonstrate different kinematics situations. And the first time he did that, I remember the all 9 of us, our entire class was laughing and giggling, and it was a great day. And then that day, I remember I finished the assignment we were supposed to be doing early, and he gave me the challenge problem to work through, and it was deriving the kinematic equations. And if you take in physics, you'll know what those are. Great equations. I texted my friend who was in chemistry, and I said, I have to tell you about this. And on the drive home, or the drive back to our school, I was like jumping out of my seat. This is so interesting. It's like math, but it has like a physical meaning, and there's a purpose, and things happen, and I understand what's happening in the world. I believe that was the day that we learned human beings are really good with a constant velocity, but we're really bad with constant accelerations. So you'll notice whenever you're watching people play sports, if they miss a catch, usually it's because it is too low, or like they end up like scooping it down low because their brain isn't great at interpreting a constant acceleration. If you know physics, in the x direction, there's nothing happening in the x direction. So you know roughly where, once the ball is released to the speed it has, your brain subconsciously knows the math of a constant velocity. And so you can get to the correct place on the field, but you don't always know how like in the Y direction where that ball is going to end up because we're really bad at interpreting constant accelerations. And I told this all to my friend, and I was giddy at this point of this explanation for the world and this better understanding I had of like an actual physical thing that I could see in the world. And then from there, I went on a YouTube deep dive into quasars, some of my favorite YouTubers, podcasts about physics and this subject of astrophysics and exploring space and explaining how like the atom works and why things happen the way they do. Very interesting. I loved it. I'm glad I did that. I still love physics. It's terribly interesting.
I think that's so cool that you had that experience kind of unexpectedly. I think sometimes the best experiences and the most like life-changing door-opening experiences really do happen from those kind of like spur of the moment, unanticipated decisions, like taking physics at that school. So yeah, I think that's really amazing that you had that experience and now you're still interested in that field. And maybe it would be something you wanted to pursue in the future. Who knows? So, are there any specific class at MIT that you found particularly interesting, either in physics or in really any field?
In physics, specifically, I mentioned, I think briefly, a course on Intro to Special Relativity, Introduction to Lorentz Transformations. We didn't get to Einstein's field equations, so let me back up. Lorentz transformations are a small adjustment that was made to Newton's velocity transformations. So Newton's equations are if you have an object moving with a speed of v, and you want to go from one reference frame to another, you basically just add or subtract the correct velocities. There's more to it. It can be a little complicated to get the velocities you're adding correct, but that's basically all it is. And Lorentz came around and these work very, very well. At smaller speeds, v equals v plus v or v minus v, basically correct. And Lorentz came around and he realized that whenever we got velocities of approaching the speed of light, so with photons or electrons or basically anything like that, these equations tend to break down and they kept getting inaccurate numbers toward the correct velocity of these particles moving at absurd speeds. The speed of light is not, it's very fast. So Lorentz had this idea, he put it forward, and people were like, but the Newton's things work so well. Why are we using these, Lorentz? Why do you have a gamma factor? It is worth noting, Lorentz's, if we take v to be very smaller than c, the Lorentz velocities equations end up going back to just Newton's equations, it's fun. So class regarding that, with Lorentz transformations, that is where a lot of the ramifications of time dilation come in and the ramifications of lens correction come in. So those are the buzzwords in physics. Time dilation is a fancy way of saying when you approach the speed of light, things get persnickety and you don't experience time in the same way. These equations are, whenever you can derive some interesting things with energy specifically, that show that mass and speed are not that different from each other. Most people know E equals mc squared. It's like the equation. And this comes from Lorentz equations. Einstein was looking at them and went, wait a second. Energy equals mass times velocity? That's strange. And it is strange. It's very strange. You get strange things from these equations. And then Einstein took that and he went, what if I make this really interesting and add in, this is where the field equations come in, which are basically Einstein's general theory of relativity. This is where he took the Lorentz transformations and he added in extremely large masses. So Lorentz transformation deals with relatively okay or small masses and extreme speeds. General relativity says very fast, very massive. It is worth noting quantum theory, which is the other, like, one of the second of the three main theories of like the world that we have. Quantum theory deals with extremely small things. Subatomic particles, things that have probabilities based on their wave functions. I don't know much about that yet. That's the later years of physics. But so the class on relativity was really interesting, very challenging and very fast, but interesting. And then I'm currently, it's less technical, but I'm in this class called 12409. It is observational astronomy. So I get to go on the roof of one of the buildings on campus every week, and I get to look at space. So right now we're sketching the stars. Last week I sketched part of Orion, specifically the Orion Nebula, located in between the triplets on his belt and then his 2 feet stars. I don't know their names. And then I also sketched, it wasn't Castor and Pollux. It was the stars in the Big Dipper, but I can't remember their names. I'm working to memorizing the names. You get some extra credit if you learn a bunch of star names. So very fun. Castor and Pollux are the twins. So if people who know more astrology might recognize them as the Gemini twins. Those 2 stars. So we're hoping to go to the big observatory soon. And that's the one off campus, a couple miles, and we'll get to use like the giant telescopes there to look into either some like nebula, planetary exoplanets, maybe some stars. We'll see what happens. So very fun.
Yeah, those both sound like incredibly exciting classes. But the astronomy one especially, that sounds really, really cool that you guys get to, see all the stars and all these other things going on in our solar system. And then sketching them sounds really cool as well. You mentioned that your interest might have shifted a little bit from astrophysics into Earth and planetary sciences, at least in regards to what you might want to pursue as a career. Is there a specific class or a lab that might have pushed you in that direction?
I wouldn't say there's a class that I've taken at MIT, only because I'm relatively green. I'm still getting my feet underneath me. I'm still exploring all the classes there are to offer here in the first place. I think in pondering the classes I've taken in high school, I've been remembering that I really enjoyed my biology class and my environmental science class. I think biology might fall into the category of chemistry for me in that I love to learn about it. I don't know if I want to go into work in that field, but it's very interesting. And then environmental science is something that it doesn't interest me in the same way that like space and observational astronomy does. But it is something that I feel is very valuable and really important and unfortunately very pertinent to the world that we find ourselves in increasingly. As science has shown repeatedly, climate change exists and it's a thing that we are facing. On that, like back in my hometown, we used to get a lot of snow, and this year they've barely gotten any, which has been a little heartbreaking for some of my friends because we enjoy the snow. And it's things like that that bring about this worry to me. I also was able to attend a course 12 mixer is what they called it. And course 12 also includes the Astro at MIT. So it's 12409 is in 12, which is awesome. I would get to take that class. It would count for my major. They also have this class called 12010, which is an introduction to geology. And you get to go and you get to learn about like rock structures and like what makes them, how they're formed. And you get to go on a 3-day field trip to some nearby archaeology sites. I can't say that word today. And I'm really excited about taking that next semester. So I think my realization that I don't want to go into the field of physics research has been more akin to me just thinking about the things that I really like and the things that I think are valuable and what I want to do with my life in the world.
Yeah, and I think climate change is such a huge thing right now. And it's something that's going to be affecting our generation and so many generations after us as well. So I think, yeah, that's really nice that you are interested in focusing on that issue and helping us find solutions to that. But so in the middle of figuring all of this out, being a first year at MIT, taking all these really interesting classes, there's something else that you are really interested in from high school and up until now. So you are someone who loves space and dragons both. And you put that to use by teaching a class on dragons at MIT, which is so, so cool. Can you tell me a little bit about what that class was actually about and how that opportunity kind of came to you?
Yes, I can. MIT has this program that they run every fall. It's called Splash. So they invite anyone who wants to come who's in high school is welcome to. It does tend to be people who are on the East Coast just due to physical constraints. The idea behind Splash is that the students at MIT, we can teach anything, talk about anything, share anything. And like I had some friends teaching about D&D. I had a friend talking about pre-Darwinian evolution, which was really fun for him. He had a grand old time. And I saw this, and my first thought was, I love dragons. I could teach a class about that. And I didn't entirely expect them to let me, and they did. Growing up, I was an avid reader, although it tended to be less of works of philosophy or literature. No, I wanted the dragon books. So I read a lot about these fantastical creatures. I took a lot of interest in the mythologies around the world. They're very interesting. There's this creature that it's not super well known. It is called, I might get the pronunciation wrong, but the impendulu. It's similar to a hammerkop, the lightning bird in a lot of mythologies in southern Africa. It is a little different in that it tends to be more stocky, more like a velociraptor with wings and lightning powers. Really interesting. Hammerkops usually are more based around cranes. They're more considered, they're more tied with the folklores of like bringing lightning and storms, etc. Mythologies are interesting. I digress. So I was preparing for this class, and the basic premise of it was I wanted to have like two discussions. I wanted to have a discussion regarding like what makes something a dragon and why they're important. And the overall thesis of the class was with most with most discussion about traits of creatures, things tend to be murky. If you've heard the common analogy of a fish, what is a fish? If you make biological claims, you have to include us. If you make taxidermy claims, you exclude some things that are a fish. If you include everything in the water, that's also a problem. It's just, but when I say the word fish, you know what I mean, roughly. So it's an interesting problem of making nice baskets for things to fit in can be challenging. An interesting thing to talk about. And then after I transitioned to the discussion of why do we care about dragons, I took what my students, because this class was more, first started with more of a lecture from me and then it's discussion. And I took what I asked them about, like, what are the traits of a dragon? And I started to ask, okay, why do we care? Through more of an anthropological lens of why are we interested in these creatures that we conquer, we slay, or in some stories, dragons are used as monsters to reach out to, something that is similar to us in some shared level of humanity among monsters. Even in other stories, dragons are used as like literary devices in terms of foiling characters or foiling actions, which is interesting. Think like The Hobbit. It's probably a better example of that. Well, it was a really fun class. I got to talk about dragons for an hour. I got to talk about why they're important to me, what I think of dragons, and the importance we have as humans for stories, and where dragons seem to fit in this push toward stories that we see in most humans. Just kind of a fun thing I got to do here. I'm very likely to teach again at Splash, probably another dragon class, or I might talk about another book that I love, but it's just kind of a fun thing that a lot of my friends and I got to do at MIT. And if you're in the area, look at Splash. If you're a bit younger, I obviously don't know who I'm addressing here, but Spark is coming up. Spark is for younger students. So Splash is 9th to 12th grade, and Spark is for 7th, 8th, and 9th, I believe. So,
Yeah, that's super cool. When I was reading your resume, I was actually really interested in that, and I thought that's such a cool thing that you got to do, and teaching about something that you're passionate about and interested in is really cool. I guess kind of tying into that, what would you say is your favorite dragon mythology story or book that you've read? I know it's a tough question.
my heart, there's so many. And I can't even like qualify this by saying like which form of dragon, like the monster form or like the friendship form. I would have to go with How to Train Your Dragon, the book series though. A lot of people know the movies, and I love the movies. I've watched the entirety of like Defenders of Berk, Race to the Edge, all the movies. I even watched the new Nine Realms show, which, putting aside my feelings about that show, I read the book series when I was young, but when I was young enough that I related very strongly to the protagonist, Hiccup, and his feelings of being othered by his community and feeling like he had these values and these desires that didn't quite fit into the world that he was born in. And then in that book series, unlike in the movies, the dragons can speak. So the dragons are presented as other beings, but still with a thread of humanity to them, a thread of like goodness or morality, or philosophers can argue about what that means. But just something that connects thinking beings together. And the betrayal, one of my favorite lines of that book series is human hearts can mend and heal. Maybe dragon hearts are the same way. And what I took from that as a young girl was even when we feel othered, we are still human and we can still live on. There are a lot of really amazing quotes from that book series. No such thing as impossible, Alvin, only improbable. A lot of amazing. I could talk about this book series for a very long time. Specifically, there is this dragon who finds that because of the love he once had, he couldn't make a hard choice because he wanted to believe that there was hope in the world and there was goodness in the world, and that history is a succession of noble failures. And it was just a very, very watershed book for me. And it shaped a lot of my beliefs and my values and the way that I approach the world and other humans, etc. Read that book. Amazing book series.
Yeah, I've actually heard a lot about that book. I've watched the movie, and then the TV series as well. I'll have to check that out. That sounds great. But so what do you think it is about dragons that makes it so important across so many cultures in terms of their stories, their beliefs, and just their imaginations as well?
Okay. There's so many ways to answer this question. Like in the class that I gave, I had like a bullet list of why are we drawn to these creatures throughout most of society? Because you may have heard the belief that in almost every culture there is a dragon-like creature. Most of us have this idea of reptilian-like creature, either monstrous or misunderstood, that is out there and that is something dangerous and perhaps scary. This is a common, like, cultural story thing. It is worth noting that the differences between the dragons are very stark. Obviously, in more Eastern dragon lore, you have benevolent, snake-like, ethereal beings, whereas in more Western or, like, European, Welsh dragons come to mind, which are, like, the dog-looking gremlin creatures that go for the ankles. Very different representations of a dragon. That's, again, going back into the more of the how do we classify as creatures question. But I would contend that like the two to three main reasons that we are drawn to dragons is there's a quote that I kind of remember who said it, but it's stories are important not because that they tell children that dragons are real, but because they tell children that dragons can be beaten. So if we're going off of dragons whose role in the story is to be this otherworldly great entity of danger, that's kind of their role. To show us that I think most of us are aware that the world can be a difficult place. It is not always the kindest place to people. Reality is hard, but we know that. And dragons of that kind of like type fit into the category of showing us that we can beat those dragons. Anything worth having takes work. The dragon's hoard is guarded by the dragon, but on the other side is a hoard, like gold, treasure. So those kind of dragons fit into that narrative style. And then the other like main one I would contend is the How to Train Your Dragon style, which is feeling othered. Again, I think this is a very universal feeling. A lot of us, whenever we first leave home, when we first go to college, when we get our first job, et cetera, et cetera, et cetera, or even before that, if you're in high school, feeling this now, if you're in junior high, feeling this now, there are moments in our lives when we feel we don't fit into the culture we were brought up in, or when we feel like we don't entirely fit into the world. And dragons in this sense are more like the misunderstood monster, which is a different literary role, tool, whatever you want to call it, that helps us see that something that is monstrous can also be reached out to. In the How to Train Your Dragon book series, it's very clearly that Hiccup reaches out, I'm specifically talking about the movies, Hiccup reaches out to Toothless and he finds a creature who was just as scared as he was, something that related the two of them. And he found this really valuable bond with Toothless. And I think for a lot of humanity, thinking of these creatures as things that with enough love and understanding can perhaps be connected to is a very human desire. I think those are kind of the two main categories dragons fall into is a beast to be slain or a beast to be understood. And then the third one is kind of creatures that are like us. If you know like Wings of Fire, that's a well-known dragon series, where the dragons are basically just humans. That one, maybe it's more just the interest in considering other cultures, considering other like world building things, using our imagination. So fundamentally, maybe less about the human, like the nature of human experience, because the dragons are basically humans with dragon skins on. But it's still interesting to think about. And why do we value sci fi? Why do we value high fantasy? These worlds, these things that are not reality, but are still interesting to think about and consider. And yeah, that's kind of my thesis of dragons.
Yeah, I think that's so interesting. I've definitely never thought of dragons in that kind of like philosophical way, in terms of like thinking about like their deeper meaning in human life and how humans approach life. So I think that's really, really interesting. And I'll definitely have to read more about that too in my own time. But what is one interesting or fun fact that you think everyone should know about dragons?
If you think something is a dragon, it's a dragon. That's my fun fact. That, or there are a surprising number of people like me who talk about the philosophy of dragons. I got a book from a friend recently. It's in my bag that I need to read. That's like talking about basically my class, but like an actual philosophical discussion of it. There's videos online. It's really interesting to think about that we're all a little bit interested in these creatures. That, or when I was younger, part of what got me interested in like STEM, learning about biology and science and physics, part of that drive was I wanted to prove that dragons could theoretically exist. And again, with enough science, you can make it work. The hardest thing is evolutionary like pushes, because there are some species that do have fire breath or acid. We know acid exists. There are cobras that spit venom. There are snakes that spit venom. There is some type of snake. I might get it wrong. Biologists are screaming at me. We know that that mechanism exists, but the biological factors for a big lizard with specifically that power it's fuzzy at best. And then dragons with wings, ooh, the physics of flying fall apart really fast. The most viable one is a wyvern, specifically with an acid-based attack. So if you want to tell your friends, acid-spitting wyverns, next big evolutionary step for the world.
Yeah, that's really interesting. Wow. I've never like thought about dragons in like this kind of light before. So I think that's always it's always interesting to learn new things about different topics. So yeah, I think that's really cool that you have that interest and you were able to share it with kids in high school as well. So I think that's awesome. But kind of shifting gears a little bit, I'd love to talk a little bit more about your experience as a woman in STEM. So you are involved with the undergraduate women in group. What has it been like to be a part of that kind of community at MIT?
Really helpful. So before coming to college, and this is a subject I've been talking to some of my friends from home with, I, as a woman, was aware that sexism existed, that misogyny existed, but I had never had it happen to me. I had never really given it a lot of thought when I was younger. I think being more in the world as an adult in the world, I'm noticing it more. And I'm realizing that it actually is a thing that people do. And looking back, even at some of my experiences when I was younger, there were people who underestimated me because of who I was for a plethora of reasons. But it's really interesting to think about. So coming here and being able to meet and talk to women who are also interested in physics, or even who are not. I have some friends who are interested in nuclear engineering. I have some friends who are interested in American manufacturing. I have friends who are really interested in like chemistry, and some with preventing diseases. Meeting people who are like women also really interested in these things has been really helpful for me. And then specifically UWIP, I've been able to talk to the small number of physics professors at my college. I've been able to talk to other women and talk about their experiences. And it's not overtly like, people are not often going to say to you, well, you're a woman, you can't do that. That doesn't happen as much. It's more of just like a kind of assumption that you're you, which can be somehow still cutting. I think the best part of UWIP, however, was a couple of weeks into the semester. The people who run UWIP put out a form saying there is this show running in Central. It's called Silent Sky, right? Yeah, Silent Sky. And who wants to go see it? And I had the privilege of seeing this show about a year and a half ago during its first run at SUU, so Southern Utah University. that was the first run. Like the director was the writer of the show. It was really incredible to be able to go see it. Me and like two other people were able, like only a few people in my Shakespeare ensemble. I also do theater. I didn't mention it very briefly, but we were able to go see this show. And it's about Henrietta Leavitt and two other female astronomers who were at Harvard in the 90s during some really important times during the suffrage movement, during when they were revitalizing the spectroscopy system. So if you're aware, OBAFGK, the spectroscopy star classification system, the woman who changed it was a couple of Henrietta's friends. So this play is about those three and their friendship and just exploring these really important themes of like belief and science and a little bit on the subject of love, but specifically love for your work and love for like a field that interests you. And amazing show. So when they put out this forum, I was like, oh my goodness, I need to go see this again. So I was able to go with a couple of my friends, two of which are actually in concourse. So we see each other pretty often. And those two want to go into course 16, which is aerospace engineering. So physics adjacent, still astro, but just different flavors of it. And along with a couple of people, sitting with other women who are interested in physics and watching this show that moves me to tears. Oh, it's beautiful. Was an incredible feeling. And like we got to discuss afterward about like the fact that Henrietta Leavitt is kind of a hero to a lot of us. Like she's a woman that we know and who did this amazing work at she was part of the reason that they figured out cephalids, that's the word. Stars that blink. So a problem that astronomers were facing during that time period was how to distinguish between stars that are really bright and far away versus stars that are really close, but not as bright. And what she kind of figured out was the flickering of these stars could be measured. And like a symphony, the play took on some like liberties of like a symphony because of her sister's musical talents, but I digress. The idea being that there was this scientific way to figure out mathematically what stars were far and what stars were close by. And then from there, you can figure out the correct spectroscopy and classify stars correctly, which is really important and really interesting work. But like, I got to talk to my friends about this, and after the show, we thanked the actors because this is a thing that means so much to us as women who want to learn more about this field. And I do want us to learn more about physics. I'm likely to minor in it. I love physics. And it's just so interesting. And then there is the ending of the play has this beautiful line that goes, "That's why we measure it all in light." Specifically in regards to like the fact that time keeps moving forward and that our lives will end eventually. And it was just like a very philosophical way to tie in space and the universe and the fact that the universe may be indifferent, but we don't have to be. Incredible show. And so UWIP letting me be able to see that again, incredible. Besides that, we have bi-weekly dinners. I connect to the people in those dinners somewhat. With Concourse, I do have a different class for my physics classes right now, so I don't have the ability to talk to them about P-sets as much, which can make for small difficulties, but we still all love physics. So I would contend it's been really important and really happy and satisfying for me to meet other women who are also interested in physics. There's something important about meeting other people who are passionate about something you're passionate about and being able to see that, oh yeah, I can do this too. I can learn about this field. That's very inspiring.
Yeah, I think it's always so incredibly important to have that community where, you can connect on your similar interests. And like you said, see that other people are in this field, are interested in this field, and that you can do it too. And that representation is really there. There are more women coming into STEM and the retention rate is getting better as well. So I think always seeing that there are other people who have that interest is just really inspiring and really motivating to keep going and just keep pushing in that field. But so physics is still a pretty male-dominated field. Has being surrounded by other women affected how you experience or approach the field at all in terms of anything you might have learned in classes or in UWIP, or really in any other part of your life?
I think the biggest way it's impacted me is, so I'm a relatively involved person, specifically in the field of physics. I've noticed that it tends to be the women who are Like for my phys pop, I'm going to go back to that. It was, if I remember correctly, it was majority women who were running that and who were reaching out to the new students. Even though the phys pop itself was, I think, slightly more male, but not by much. Again, I one of the benefits of going to a college like MIT is that there are applicants from around the world, and so you get a lot of really diverse experiences, a lot of diverse interests, and it tends to be, in terms of classes, more equal on like male men and women. That isn't to say I don't know that doesn't happen. I have a friend who's going to college in Utah, and her engineering major, it has like 4 women, I think. Yeah. I think for me though, the biggest thing is like the people that I am connecting to in terms of advisors or mentors. That's what I was looking for. Through UWIP, I was able to connect to a graduate student. She is currently working. She's an aerospace student, so again, slightly to the left of more of my interest in physics, but still very valuable and still very admirable in what she does. And she's been able to talk to me about like part of her journey and part of the realities of being a woman in this field. And so that's been very helpful. And then I know 2 other women, both of them who are concourse upperclassmen, who have been willing to talk to me about some of their struggles and some of the reasons why they considered physics and why they went back to it and why they're still interested in it and their plans for the future and the challenges they've faced. So for me, the community that I found myself in for physics is predominantly women because of UWIP and concourse. The the people who are interested in physics tend to be women. That isn't to say I don't know some students who are male who are interested in physics, but I have not interacted with them as much. I met this girl on like the first during orientation week, and we hit it off. And she's a physics major, so at the time when I thought I was going to be a physics major, we discussed about like our love for it, and I'm still likely to be involved in physics. As a course 12 major, I will be adjacent. Like it's more left, even more to the left, but it's still adjacent to physics.
Yeah, I think having, like what you said, having those mentorship relationships and just having people you can look up to or talk to, talk through your struggles, your love for physics, and just getting to talk through your experiences with other people is always so valuable. So you mentioned briefly in the show that you had watched that there were some figures who you found really inspiring. Are there any women in STEM, whether they be people you know personally or fictional figures or historical figures, who have really inspired you along the way?
Good question. I think for me, a lot of my teachers in high school were really inspirational. They had a lot of faith in me. And obviously it wasn't just women. Like I've had some male teachers who were also very proud and very excited to see where I went. Like the physics teacher I mentioned, he was really supportive of me and he was really, I believe I sent him a graduation announcement, even though he didn't even go to my school, just because of how much faith he had in all 9 of us, specifically women though in my life. My calc teacher in high school was really, really important in supporting me throughout all of my high school years. My yearbook advisor, I'm not saying their names just for sake of their confidentiality. My high school yearbook teacher and my environmental science teacher was also pretty important to me. My teacher in 6th grade, actually, I was able to see her throughout the years as I went through high school. I went back to my elementary, and every time I told her what I was doing, she was incredibly proud of me and incredibly happy where I was going. She taught the science curriculum at my school, like for 6th graders. Specifically, I think we talked about plate tectonics and geology, which I am also interested in. It's geophysics. It's like physics still. So that was pretty important for me. Henrietta Leavitt, obviously, as I've talked about her, I love her. Annie Cannon was the woman who I believe changed the OB. Oh, Wilhelmina Fleming is the other woman in Silent Sky, who is also someone I consider to be an inspiration for me. And then this is tying into my culture as a woman from Utah. So Utah has a very particular and strong religious culture. And in that, there is a woman named uh, Emma Smith, who learned science. And despite a lot of difficulties in her life, she had a lot of faith and a lot of hope for the world. And I think growing up, I definitely saw her as a woman that I wanted to emulate and wanted to retain that kind of hope for the world. But that's a very, very niche cultural woman. She's not as well known.
Yeah, I think that's incredible that you had so many people who you could look to for inspiration, who are always so proud of you and motivating you to keep pushing. So I think that's so incredibly important to have people you can kind of like fall back on and really look at for inspiration. So I think, yeah, that's really great that you had those figures. So it sounds like your community has been super strong throughout in terms of being a woman in STEM and helping you like keep that motivation and that love for the field. So I'd love to talk a little bit more about some of the work that you're doing right now. You are a freshman in a research lab at MIT. What did that process kind of look like for you in getting involved in research so early?
Ooh, good question. So MIT is kind of unique with the way that they present research. Even as a freshman, there is a specific financial fund. The basics of it is if you do a research project over IEP being the month of January, basically. We don't start our spring semester until February. During IEP, if you apply for Europe and work with some lab on campus, you are guaranteed to get direct funding from the school, provided you didn't do a Europe during first semester of your freshman year. Definitely put in place to incentivize people to get involved in research early, to start building connections to people in their field or even not in their field, to just faculty or graduate students, etc. So during IEP, I was privileged to work with a lab on campus working to put a satellite into space. I don't think I'm supposed to say much about it, but basically what I just did some grunt work, some documentation that needed to be done. Let's just say I am in the process of learning. I'm learning a lot of things. You hire an intern knowing that they don't know how to do things to teach them. That was what my first year up was like. My current year up is with a different lab. It's with Star Lab on campus. And I'm working with simulations, specifically using some code that's been written to simulate Milky Way-like galaxies. Ooh. This is what some of the work of astrophysicists do. Depends on the astrophysicist, obviously. Not all of them are going to be doing a lot of coding, simulation work. Some of them, like one of my teacher for 12409, does more observational work, which I think is something I'm interested in. But with the simulation of the galaxy like Milky Ways, my project is to look at these simulations and see if there is some kind of correlation or possible explanation for why we see different radii of different merger events. A merger event being throughout a galaxy's life, whenever two galaxies get too close, they start to spin together. You may be aware that we're on a collision course with the Andromeda galaxy, and eventually we will spin together. Our black holes in the center of our galaxies will combine, and there will be a new Andromeda Milky Way galaxy. We may not even notice, depending on what happens. It's hard to tell at this point, and this is very far into the future, so we don't need to worry about it. But it's interesting to think about. And those kind of events have happened throughout our own galaxy's history and throughout the history of many galaxies. So the idea behind my project is looking at this and trying to model it, and specifically in regards to dark matter. It's kind of the catch-all term for this phenomenon we see where there is more stuff in the universe than we expect. It's called dark matter because none of us really exactly know what it is. We just know that it needs to be there to make our math work. And we're pretty confident that the field equations work really well. Dark matter, question mark? It's a strange phenomenon. It's really interesting. There are more resources well-versed on this than I am. If you're interested, go on a little deep dive. There are plenty of research papers. There are plenty of scientists talking about this. It is the edge of physics right now. So my project isn't specifically in regards to dark matter, although my lab at large is looking into a different model of dark matter. That current models of dark matter present it as a particle that only interacts with gravity. There is some thought in the field right now of what if dark matter interacts with itself in terms of the weak force and the strong force. The four fundamental forces of physics are gravity, strong force, weak force, and electromagnetic force. These three are way stronger than gravity is, but dark matter originally, when we first created the concept of our models, it was only a gravitational particle. And now physicists are wondering, what if gravity is... No, sorry, gravity. What if dark matter also interacts with itself with a weak force or a strong force or an electromagnetic force? What would that mean? That's the current thought behind a lot of research labs and what we're thinking about, what we're trying to solve. This is knowledge you can read about. Two of the graduate students, they recently posted some papers about their work currently. So very interesting, very open to the public. Read research. It's really cool. I get to work with the current cusp of physics.
I think that's so exciting, especially because you've been interested in physics for so long. So getting to really be at this forefront of this research is super, super cool. And yeah, it sounds like the work that you're doing is super exciting. And that sounds really interesting as well to see how this dark matter can interact with itself instead of just what we know now. So I think that that's really interesting. But you've done so many incredible things. You're part of incredible organizations, and you've had so many experiences. So I guess kind of zooming out a little bit and looking at things from a more reflective manner, looking back over just the past year, what's something about studying physics or just being a student at MIT that has really surprised you?
I think it's surprising how easy it is to get lost in the trenches. What I mean by that is I'm a person who loves to learn. That's why I'm at the school that I'm at. It's something that I've put a lot of value in this continued learning about people and stories and science and what we're doing with our lives. And sometimes when I'm in the middle of a P set or studying for an exam, it's easy to feel or forget that I'm doing something I love because I'm so focused on just trying to do the things I need to do, trying to just learn what I need to learn. I've had to keep myself positive about the fact that I'm doing what I love. Even though it's hard, I am doing what I love. And I have this amazing opportunity to study under people who are currently doing research, to meet with some of the brightest minds in our world. That's an incredible thing I get to do. I think it is surprising to me just how supportive the community at MIT is. Again, coming back to the discussion we had earlier about people not being competitive, even beyond that, people are willing to help. People are willing to explain it to you. They're willing to say, this is what helped me. Maybe you can try it. People want you to succeed, even though it is very challenging. And again, I didn't have that perspective at MIT when I heard about it. I mean, as a girl not from the city and not well versed on the world, I had this very distinct image of MIT in my mind of like penthouse buildings and a bunch of like really nerdy people like at each other's throats, competing with each other, a bunch of computer science people. And the parts of MIT that I find myself connecting to the most just aren't like that. It's a very supportive place in terms of academic.
Yeah, and I think that's incredibly important, to be in an environment like MIT where everyone is pretty like-minded in terms of, they're very high-achieving students. They're all very interested in genuinely learning. Like, they have a love for learning. I think having a supportive community who's all willing to build each other up and bring everyone up together is so important. So it's great that you've found that community and that environment at MIT. So looking ahead, what's something that you're especially excited to keep exploring over the next few years?
I'm really excited to learn. I want to explore working in science communication. I hadn't put a lot of thought into it before a conversation with a friend. During my small crisis of what am I going to do with my life, with my major, with my career, I was talking to a friend and she mentioned that maybe I could find a job working to explain science to people or concepts about like, if you picture like your again, like science videos are things I really enjoy. People breaking down science, very difficult concepts into things that are understandable or using examples like explaining capacitance as people on a sidewalk. Very helpful for understanding electricity and magnetism. And so I'm interested in looking more into that as something I can do maybe. Because I think it'd be really cool to be able to talk to people and be like, hey, do you want to learn about science as a job? And to be able to present these really interesting current advancements in the field of chemistry, biology, physics, all of these really important STEM and human advancements that we constantly have in our world. And being able to explain that to the general public is really important and really cool. So I'm excited to learn more about that. I'm also really excited more to there's some classes in my school called D-Lab. It's more engineering based, but you basically work on a project for all of a semester, and then during IEP you can go to some place and use that project to actually help people or talk to people making laws and explain like why your project is helpful, or basically a very boots on the ground, helping people doing engineering work that helps people. I'm really excited to look more into that. And then obviously classes on geology, classes on physics, on quantum theory, learning everything that I possibly can while I'm here is something I am looking forward to.
Yeah, I think there are just so many opportunities for you to explore, and you have so much time to explore it in college. So yeah, just enjoy that. But what you were saying about science communications, I will say in this conversation we've had, you've been really, really good at explaining topics. So I think you would be great for that. Sounds like you have a lot of exciting things ahead of you, and I wish you the best of luck in that. But for my final question, if you had to give your younger self one piece of advice, what would it be?
With the dreaded question. I have asked that question to so many people, and being on the receiving end, I suddenly have much more respect, sorrow for them. I think what I would tell a younger me is something along the lines of, I'm tempted to quote a show that I love. You may have noticed throughout this conversation, I put a lot of value into quotes, into like words and stories. They stick in my brain. So the quote I would probably say is it's a Roosevelt quote. They use it in Newsies, but I believe it is actually Roosevelt. It's keep your eyes on the stars and your feet on the ground. You'll be fine, kid. So something like that. Or I would tell her, the world needs what you can give it, and whatever you do in life, it's going to be beautiful. Something like that. Something about the world is not always an easy place, but it is worthwhile. And there's so much good and so much beauty in it. And whatever you have to give is needed and worthwhile.
Yeah, I think that's such a beautiful message. Just, like keeping your head up and staying positive. So I think those quotes are amazing. And I also agree with you. Quotes are so important because I feel like they just encapsulate so many feelings in such a great way. So yeah, I really love quotes as well. But yeah, I think that's a really, really important message for young people to hear. Not even just young people, really anyone at any point in their life to hear. So yeah, I think that's great. But Jaylee, thank you so much for being here today, hearing everything you've done and your experiences, and just hearing about how you're still figuring things out is really inspiring. And I think it'll help a lot of younger girls who are listening to this podcast feel more seen and just feel inspired to keep thriving in the fields that they're passionate about. So thank you so much for sharing everything that you've shared today. And for everyone listening, if this episode resonated with you, please share it with someone who you think would enjoy it too, and leave us a review on your favorite streaming platform. So thank you so much for tuning in to the She Persists podcast, and until next time, keep persisting. Once again, I'm your host, Emma Zareen, and thank you so much for tuning in to today's episode of the She Persists podcast.